So the general form of a combustion reaction would be a hydrocarbon, and that is anything that has carbon, hydrogen, and sometimes oxygen. When this reacts with oxygen, we get carbon dioxide and water. Now, the states of these substances really depends on whether it was done in a closed or open system. But this is the general form of the reaction. Now, these can be complicated to balance, so it's best to approach these as systematically as possible. And one method that I have is, first we balance the carbons, then we can balance the hydrogen second, and it's really important you save the oxygens for last. Now for the last part, when we're balancing the oxygen last, what we're going to do is we're going to start counting from the product side and then choose the proper coefficient from there. So based on how many oxygens are on the product side, that's what we'll use to decide the proper coefficient. So here we have our first combustion reaction here. So like the step suggested, we're going to balance our carbons first. So we have 3 carbons here and only 1 over here. So we're going to put a 3 in front. And now the carbons are balanced. Next, we're going to balance the hydrogens. We have an 8 over here and we have 2. So what we're going to do is we're going to put the 4 over there. And now we have balanced our hydrogens over here. Lastly, we're going to balance our oxygens, but we're going to start by counting the products. And that's, of course, with the coefficients. So we're going to go 3 times 2, which gives us 6. So I like to write oxygen equals, and that'll be 6. And then plus 4 times 1 is 4. And that gives us 10 total on the product side. So in order to balance this, all we'd have to do is put a 5 here. And then these are the coefficients in our balanced reaction. So what happens if the number of oxygens that we count on the product side are odd? Well, let's look at this example here. We've got CH6 plus O2 gives us CO2 plus H2O. And as per usual, we're going to balance the carbons first. Then, like in our other combustion reactions, we're going to balance the hydrogens. We got 6 over here and 2. Put a 3. Lastly, we're going to balance oxygen by counting on the product side. So we got 2 times 2. And that'd be 4 plus 3 times 1, so 4 plus 3, that gives us 7. Then we're going to place the total, in this case it'd be 7, as a coefficient over here. So we'll put 7 like this. And then lastly, we're going to double every other coefficient in the equation. So if this had an invisible 1, now we're going to give it a 2. We're going to cross out that 2 and put 4, and we're going to cross out that 3 and put 6. And we can see here that we now have 4 carbons and 4 carbons. We have 12 hydrogens and 12 hydrogens. And we have 14 oxygens, and 4 times 2 is 8, plus 6 times 1, it's now 14 oxygens. So perhaps the most complicated of them all are when there are extra oxygens on the reactant side. So the process is similar except for the very end, where if I look at this reaction here, I see that there's an extra oxygen. So normally would there be 2? Now there are 3. So like previously, we balance the carbon first, then we're going to balance the hydrogen, and then we're going to balance the oxygen, but we're going to do this in a 3-step process. So the first step is to count the oxygens on the product side, so that's similar to what we were doing before. Then we're going to use a bit of algebra to get the coefficient that we should put in front of the oxygen on the reactant side. And to do that, we're going to take the number of, or the total product that we've counted, Right? In our case here, that's 7. And we're going to subtract it from the number of extra oxygens, anything that's beyond 2, which in this case is going to be 1. And whatever that total is of that difference, that is going to equal the coefficient that we place. So in this case, we have a product of 7, right? And we subtract it from the 1 extra oxygen that is present in the reactant side. And that would give us the coefficient of 6. After this, we're going to double all the other coefficients to fully balance our equation, much like we did with our previous odd number of oxygens reactions. So now, what I'm doing over here is I'm rewriting the reaction because just like in math, if we can simplify something, we should. So here I look, there's all even numbers as coefficients, the 2, 6, 4, and 6. Those are all divisible by 2. So when I divide them by 2, I end up with just a coefficient of 1, 3, 2, and then of course 3, and that's a balanced reaction. So we're going to apply the same method that we applied in the previous question. So first we're going to balance the carbons. So there's 3 here and there's only 1 here, to put a 3 as a coefficient here. We're going to count the hydrogens and balance them, so that's a total of 8. So we're going to then put a 4 here, 4 times 2 is 8. And then now we're going to count the oxygens on the product side. So 3 times 2, which is equal to 6. And then 4 times 1, which is equal to 4. 6 plus 4 is 10. And then we're going to take for the coefficient, right, that goes in front of this oxygen here. We're going to take the product total, which in this case was 10. And we're going to subtract it by the number of extra oxygens. So in this case, there's only 1 extra oxygen over here, so minus 1. And then that's going to give us 9. We're going to place this as the coefficient in front here. And then we're going to double everything else. And this would be the new balanced reaction.